Hey there guys, welcome to my walkthrough of the Edexcel A Level Maths Sample Assessment Material Paper 2. So it's pure maths again. My playlist with all three papers is linked down below, as is the paper itself and the formula sheet. So let's do this. Okay, number 1. F of x is 2x cubed minus 5x squared, add ax, add a. Given that x add 2 is a factor of f of x, find the value of the constant a. So, by the factor theorem, if x add 2 is a factor, then f of minus 2 is equal to 0. So, if we substitute x equals minus 2 in, we are going to get 2 lots of minus 2 cubed, which is minus 16. We're going to get minus 5x squared, so that's minus 20. We are going to get plus, no we're not, so we got a times minus 2, so that's minus 2a. And then we have plus a at the end. Now that is all equal to 0. Now minus 16 minus 20 is minus 36. And then we have minus 2a, add a, so that's minus a is equal to 0, and therefore a is equal to minus 36. Okay, number 2. Some A-level students were given the following question. Solve for theta between minus 90 and 90. Cos of theta is equal to 2 sine theta. The attempts of 2 of the students are shown below. Part A says to identify an error made by student A. So, if we look at what student A has done, they've started cos of theta equals 2 sine theta, and then they've divided through by sine and got tan of theta is equal to 2. That is the error. So I'm not going to write it down, but what they've done is taken cos over sine to be tan. That's wrong. Tan is sine over cos. So that's the answer to part A. Student B gives theta equals minus 26 point. Might help if you can see it. Student B gives theta equals minus 26.6 as one of their answers to cos of theta is equal to sine theta. Part 1 answers to explain why this answer is incorrect. So, there's 2 ways we could go about this. If we think about the graph, then what do we have? We have cos theta is equal to sine. So, in our interval, cos, it's going to look like that, where this is 190 and minus 90, and then to sine theta, it's going to go between minus 2 and 2. So it would look like that. Now we can see the point where they intersect is positive, not negative. So there is no solution for the negative values of theta. The other way that we could do it is substitute theta equals minus 26.6 into cos theta and into 2 sine theta, and you will see that you don't get the same answers. So that's not right. Okay, then part 2 answers to explain how this incorrect answer arose. So, if we look at the method, so they've gone cos theta is 2 sine theta, they've then squared both sides. Now this then is what would lead to the negative answer, because when you square root you get positive and negative answers. So that is where the wrong answer has come from. Okay, number 3. Given that y is equal to x times 2x add 1 to the power of 4, show that dy by dx is 2x add 1 to the power of n times ax add b, where a and b are constants to be found. Okay, so this is going to be a mix of product rule and chain rule differentiation. So, if we first differentiate x and not 2x add 1 to the power of 4, x just differentiates to 1. So the first part we're going to get is just 2x add 1 to the power 4. Okay, now we're going to differentiate 2x add 1 to the power 4 and not x. So we're going to get add x. Now when we differentiate 2x add 1 to the power 4, we differentiate 2x add 1, which is 2. So we're going to get a 2 out of the front. And then we differentiate the bracket. So the power of 4 comes down. So we get 2 times 4. 2x add 1 to the power of 3. Okay, so we have got 2x add 1 to the power 4. And then we have add 8x 2x add 1 cubed. Okay, so here then there is a common factor of 2x add 1 cubed. So if we factor that out, then we have 2x add 1 cubed times 1 lot of 2x add 1 add 8x. Which finally gives us 2x add 1 cubed times 10x add 1 so n is 3, a is 10, b is 1. Okay, number 4, functions. You can't spell functions without fun. So, given that f of x is equal to e to the x, where x is in the reals, and g of x equals 3 log x, where x is greater than 0 and in the reals, part A, find an expression for g f of x, simplifying your answer. Okay, so g f of x means g of f of x. So, that means then g of e to the x. Now that means wherever there is an x in g of x, it becomes e to the x. So this then is just going to be 3 log e to the x. Now remember that the natural logarithm and e, or e to the x, are inverse functions to each other. So log e to the x is just x. So this is just 3x. Okay, then part B wants us to show that there is only one real value of x for which g f of x is equal to f g of x. Okay, so for that we are going to need to find f g of x. Okay, so f g of x is f of g of x. Which is f of 3 log x. Okay, now then, that's going to give us e to the 3 log x now, by the rules of logs, 3 log x is log of x cubed. So we have e to the log of x cubed now again, e and log cancel each other out, so this is just x cubed. Now then, we wanted to show there is only one solution to gf equals fg. So, if we now set x cubed equals 3x, now here it might be tempting to divide through by x. Don't do that though, because you will lose a solution. So, if we subtract 3x, we get x cubed minus 3x is equal to 0. Factorize, we get x times x squared minus 3 is equal to 0. Now then, this tells us that x can be 0 or x squared is equal to 3, which means that x is plus or minus root 3. So, at that point, you might be thinking, but we only wanted to show there was one solution. Well, we're not done. Remember that g of x is equal to 3 log x, where x has to be greater than 0. You can't take log of 0 or negative numbers. So x cannot be 0 or minus root 3. So x is only positive root 3. Cool. Okay, number 5. The mass grams of a radioactive substance T years after it was first observed is given by the equation m is equal to 25e to the minus 0.05 t. According to the model, part A, find the mass of the radioactive substance 6 months after it was first observed. Okay, so the only thing to look out for here is that t is the number of years. So after 6 months, that means t is equal to 0.5. So we just whack that in, so we get m is equal to 25 e to the minus 0.05 times 0.5. And that to one decimal place gives us 24.4 grams. Okay, then for part B, we want to show that dm by dt is equal to km, where k is a constant to be found. Okay, So that just means then, well, we need to differentiate. So if m then is 25 e to the minus 0.05 t, and then when we differentiate, we just differentiate the power, and then that comes down the front, and then the e term stays the same. So we're going to have dm by dt is minus 0.05 times 25 e to the minus 0.05 t. Which is just minus 0.05 m. Which means k is equal to minus 0.05. Okay, number 6. 6 marks altogether, so we want to complete the table below. The first one has been done for us. For each statement, we must state if always true, sometimes true, or never true, and giving a reason for each case. So, for the first one, the quadratic equation, ax squared add bx at c is equal to 0, where a is not equal to 0, has two real roots. So, hopefully we know that's sometimes true. They've given the explanation. You can read. Okay. So, for our first one then, when a real value of x is substituted into x squared minus 6x add 10, the result is positive. So, before we can state an answer, we need to do a bit of workings out. So, to test whether a quadratic is always positive or always negative, we need to write it in the completed square form. So, x squared minus 6x add 10 well, in completed square form, that's going to be x minus 3 squared then we have the plus 10, but we need to subtract 9, so that's going to give us plus 1. Now, we know, because we're squaring, this is always greater than or equal to 0. So, because we're then adding 1, x minus 3 squared add 1 is always greater than 0. Therefore, always positive for real x. So we need to tick always true. Okay, then for the next one. If ax is greater than b, then x is greater than b over a. Okay. So, we need to be very careful here. If a is positive, then that does work. The problem comes from when you divide or multiply inequalities through by a negative number, the direction of the sign flips. So, this is only going to be sometimes true. Now, for our reason, let's say if a is greater than 0, then ax greater than b does imply that x is greater than b over a. If, however, though, a is less than 0, so negative, ax greater than b, implies when you divide through by a negative, again, the sign flips. So x would now be less than b over a. Okay, and for the third one, we are given the difference between consecutive squares is odd. Okay, so for that one, we might have done this one at GCSE, it does pop up. So for this one, let's say our two consecutive numbers are n and n plus 1. Then we have n squared and n add 1 squared. Now, n add 1 squared is n squared add 2n add 1. Now the difference then, n squared add 2n add 1 minus n squared is equal to 2n add 1, which for integer n is always odd. So that one is always true. Okay, number 7, it wants us to use the binomial expansion in ascending powers of x to show that the square root of 4 minus x is equal to 2 minus quarter x add kx squared add blah blah blah, where k is a rational constant to be found. So essentially find the first 3 terms in this binomial expansion. Okay, So, first of all, we need to turn the square root into a power. So, we have 4 minus x to the power 1/2. Now, for negative and fractional powers, we use this guy down the bottom, 1 add x to the power of n. Now the problem we have at the moment is that we don't have a 1. So, what we're going to do is take out the factor of 4. So, in the front, we have a 4 to the power of 1/2. And then inside the bracket, we divide by 4. So we get 1 minus x over 4 to the power of 1/2. Now, 4 to the power of 1/2 is 2. So, we are going to have 2 lots of the expansion of 1 minus x over 4 to the power of 1/2. Okay, so we're going to have then, we're going to keep our 2 on the outside. Right, now then, inside, our first term is 1. Then we have add nx. N is the power, so we have add 1/2 times x. Although here for us x is minus x over 4. And then we have add n times n minus 1 times x squared over 2 factorial, which is just 2. So, we have add 1/2 times minus 1/2 times minus x over 4 squared over 2. And that's all we need, so we could put a plus dot dot dot. Okay, so we have 2 lots of 1. Now 1/2 times minus x over 4 is minus x over 8. Okay, now that we have 1/2 times minus 1/2, that's minus 1/4. And then we're going to have x squared over 16. So 4 times 16 is 64. So up to there we have minus x squared over 64. that is being divided by 2, so that's going to give us minus x squared over 128. Okay, now we just need to let the 2 inside. So this is 2 minus x over 4 minus x squared over 64. Okay, then for part B, we're told the student attempts to substitute x equals 1 into both sides of this equation to find an approximate value for root 3. State, giving a reason if the expansion is valid for this value of x. Okay, so this comes down to, we're told that for the expansion of 1 add x to the power of n, the modulus of x must be less than 1. So, for this one to be valid, so for we don't care about the 2 we had on the outside, so for 1 minus x over 4 to any power to be valid, to the power of n, to be valid, the modulus of x over 4 has to be less than 1. Now, we can take that 4 out of the modulus because it's just a constant. So, which means then that 1/4, the modulus of x is less than 1. Multiply by 4. Mod x then has to be less than 4. So, the expansion is valid for x equals 1. Okay, number 8, nice bit of geometry. So, figure 1 shows a rectangle ABCD. The point A lies on the y-axis and the points B and D lie on the x-axis as shown in figure 1. Given that the straight line through the points A and B has equation 5y add 2x is equal to 10, part A, show that the straight line through the points A and D has equation 2y minus 5x is equal to 4. Okay, so quite a bit of information to process. So we know we are dealing with a rectangle, so that means then that A, B and A, D are perpendicular. So, what that's going to allow us to do is work out the gradient of AD. AD. Okay, so the two lines that we are playing with then are the ones that meet here. Now, we know the line passing through AB is 5y add 2x is equal to 10. Now from that we can get the gradient of AB. So if we rearrange, we can get that y is equal to minus 2/5 x add 10. Now that then tells us that the gradient of AB is equal to minus 2/5. This allows us then to get the gradient of AD. The lines are perpendicular, so the gradients are negative reciprocals of each other. So the gradient of AD is going to be positive 5/2. Now, to find the equation, we are going to need to know a point on the line. So, we can find the coordinates of point A. So we know that point A lies on the line 5y add 2x is equal to 10. So A lies on 5y add 2x is equal to 10. Not only that, it is also on the y-axis, so that means that x is equal to 0. Now, from that, we can get that 5y is equal to 10, and y is equal to 2. So, we now know the coordinates of point A. They are 0, 2. So, now that we know the gradient of AD, and we know a point that lies on the line, we can find the equation. So, we know then that AD is of the form. I'm going to use y equals mx add c. You can use y minus y1 equals m times x minus x1 if you prefer. So we know then that AD is of the form y is equal to 5/2 x add c. Now we also know when x is 0, y is 2. So that tells us then that c is equal to 2. So y is equal to 5 halves x add 2. Let's just have a look at the form they want it. So we want it as 2y minus 5x is equal to 4. So if we multiply through by 2, 2y is 5x, add 4. Subtract 5x. 2y minus 5x does indeed equal 4. Okay, then part B wants us to find the area of rectangle ABCD. So to do that, we need to find the length of AB and the length of AD. Now that we know the coordinates, the equations, no problem. So what we need to do is find the coordinates of point D and point B. Now for point D, we know down here y is equal to 0. Now when y is equal to 0, we get minus 5x is equal to 4. So x is minus 4/5. So that is the x coordinate at point D. So from that we can find the length of AD. So it's going to be the square root of minus 4/5 squared, which is 16/25. Add 2 squared, because that's the height of this triangle. So that's add 4. Now 4 is 125, so this is 116. The square root of 116/25. Okay, so I'm going to leave it like that for now. And then we need to find the length of AB. Now we know the equation of AB is 5y add 2x is equal to 10. Now we know down here y is equal to 0. Now when y is equal to 0, we get that 2x is equal to 10. So x is 5. Okay, so this time the length AB is the square root of 5 squared add 2 squared, which is root 29. So then the area of the triangle, the area of the rectangle, I know my shapes. So the area, go down here, is root 116 over root 25. Sorry, root 116 over 25 times root 29. Which actually works out a lot nicer than I expected. So that will give you 58 fifths. Or 11.6. Boom. Okay, number 9. Given that a is constant and the integral between 1 and 4 of 3 root x add a with respect to x is 2a squared, we want to show that there are exactly 2 possible values for a. Okay, so what we're going to need to do is carry out the integral, substitute the limits in, set that equal to 2a squared and solve. So, okay, so the integral then between 1 and 4. Now I'm going to call it 3 root x, 3x to the 1/2. Add a with respect to x. So we know that that is going to be, so x to the 1/2 integrates up to x to the 3/2. We then divide by the new power. So when you divide by a fraction, you flip it over and multiply. So we're going to get 3 times 2/3 x to the 3/2. So that's just going to give us 2x to the 3/2. And then a just integrates to ax. Okay, so when we stick 4 in, we get 4 cubed, which is 64, square rooted, which is 8. So we have 2 times 8, which is 16. Add 4a. And then we have minus 1 to the power of anything is 1. So we just got 2 minus a. Now, we know that is equal to 2a squared. Okay, so we have 16. Sorry, that a there should have been positive. So we have 16 minus 2, which is 14. So we have 14. Now we also have 4a minus a, which is 3a. And that is equal to 2a squared. Now, this is a quadratic, so we want to get everything on the same side. So we can get this down to 2a squared minus 3a minus 14 is equal to 0. Now, they never said that they wanted us to find these two values of a, just to show that there are exactly two. So now that we have a quadratic, we can now just use the discriminant to show, hopefully, that this has two real roots. So, little a is 2, b is minus 3, and c is minus 14. Which means then b squared minus 4ac is minus 3 squared, so 9, minus 4 times 2 times minus 14. So that's minus 4 times 2 is minus 8. Minus 8 times minus 14 is a number. It's going to be positive. And it's going to be 112. Altogether then, that's 121. Now 121 is greater than 0. Now that means then there are two real roots. Therefore, there are two values of a. Exactly two values of a. Okay, number 10. In the geometric series, the common ratio is r, and the sum to n terms is Sn. Given that the sum to infinity is 8/7 times S6, show that r is plus or minus 1 over root k, where k is an integer to be found. Okay, so we're given the sums for geometric series, so what we're going to do is plonk these into the equation and hopefully do some magic. So, we know then the sum to infinity is a over 1 minus r, where a is the first term. So, we know then the sum to infinity a over 1 minus r oops, when you got your pen out. So, a over 1 minus r is equal to 8/7 times the sum to 6. Now the sum to 6 is going to be A times 1 minus R to the 6 over 1 minus R. So we're going to put that A with the 8, and then 1 minus R to the 6 over 1 minus R. Okay, so we now want to solve this for R good times. So, both sides have a 1 minus R on the bottom, so we can multiply through by that. So we then get A is 8/7 A times 1 minus R to the 6. Both sides have an A on top, so we can divide that away, which gives us 1 is equal to 8/7 times 1 minus R to the 6. Now, if we multiply both sides by 7 and divide by 8, we get 7/8 is equal to 1 minus R to the 6. Now, if we add R to the 6 and subtract 7/8 on both sides, we get R to the 6 is equal to 1/8. Okay, so at this point, do we want to 6th root 8? No. What we can do to it is cube root it. So, if we now cube root both sides, we get R squared is equal to 1/2. So, and if we square root, we get that R is plus or minus 1 over root 2. Therefore, K is 2. Okay, number 11, we have some fun with modulus graphs. So, figure 2 shows a sketch of part of the graph of y equals f of x, where f of x is 2 dots, the modulus of 3 minus x add 5, where x is greater than or equal to 0. Part A, on test 2, state the range of f. So the range means all of the y values that the expression can take. So we can see there is a minimum point here Now the range then is going to be anything bigger than and including the y value at this point. So that is going to occur when, so the minimum occurs when x is equal to 3 and the minimum is, so the minimum is that y is equal to 5. So the range is such that f of x is greater than or equal to 5. Okay, then part B wants us to solve f of x is equal to 1/2 x add 30. So, for this, I'm going to think about the graphs a little bit. So, we know that f of x is defined such that x is only greater than or equal to 0. Now, we know when x is equal to 0, f of x would be 2 times 3 add 5, which is 11. So the y-intercept of f of x is 11. Now, for y equals 1/2 x add 30, the y-intercept is 30. So, y equals 1/2 x add 30. It's going to look something like that. So, any point of intersection is going to be on the part of the modulus graph where the gradient of the line is positive. So, let's say the intersection occurs when the gradient on f of x is positive. So that means then that we can't be dealing with 3 minus x, we're going to be dealing with x minus 3. So, or you can stick a minus on the outside of the 2. But remember, you do that with moduluses for solving an equation. So, if we were doing this one with all values of x, we would have to do 2 lots of x minus 3 add 5 is equal to half x add 30, and 2 lots of x minus 3 add 5 is equal to half x add 30. But because we are in a restricted domain, we're only doing the one where x is positive. So we are setting 2 lots of x minus 3 add 5 equal to half x add 30. So 2x minus 6 and then add 5. So minus 6 add 5 is minus 1 is equal to half x add 30. From that we can get 3 halves x is 31. 3x is 62. So x is 62 over 3. Okay then, for part C, given that in the equation f of x equals k, where k is a constant, has two distinct roots, we want to state the set of possible values for k. Okay, so for this we need to think about the line y equals k. That is a horizontal line going across from y equals k. So let's draw ourselves a horizontal line. Okay, so at the moment, if this line was right there would be no distinct values, or the line does not intersect the graph above, so this would be invalid. If k was 5, it would only hit the graph at one point, so that would be invalid. If we move up, we're now in a region where there are two distinct points of intersection. So here, this value of k would be cool. And it would be alright anywhere between, or anywhere above 5, all the way up to that point there. Now that point is where k is equal to 11. If it goes anywhere above, there would now only be one point of intersection. So k needs to be somewhere in there. So k needs to be greater than 5. It's allowed to be 11 though, so it has to be less than or equal to 11. And we should probably also say k has to be real. Cool. Okay, number 12. Solve for x between minus 180 and positive 180. So we're in degrees. The equation 3 sine squared x add sine x add 8 is equal to 9 cos squared x. Giving your answers to two decimal places. Right, and it's 6 marks. So, fun. Right, what we need to do is reduce this into an equation involving just one function. So, given that sine is dominant, we're going to get rid of the cos. So, we can say then that this is 3 sine squared add sine add 8. Now, 9 cos squared is 9 lots of 1 minus sine squared. So that's 9 minus 9 sine squared. Okay, get everything on the same side. So if we add 9 sine squared, we get 12 sine squared. Add sine. And then we're going to subtract 9, so we get minus 1 is equal to 0. Now then, can we factorise that? I think so. I think we can make it work with 4 and 3 sine x. So, let's try it. Okay, so that takes care of the 12 sine squared. We want to end up with a positive 1 sine x. So if we have plus 1 times 4 sine, then we're going to have minus 1 times 3 sine. And that does the trick. So now we have 2 equations, either 4 sine x minus 1 is equal to 0. Now that gives us sine x is equal to 1/4. Or 3 sine x plus 1 is equal to 0. So sine of x is equal to minus 1/3. Okay, right, gonna change the colour of one of those. Okay, so now we want to solve these. So I'm gonna draw a sketch of sine of x. Okay, so we're in the interval minus 180 to 180. Okay, now then, let's first of all then do sine of x is equal to 1/4. Okay, so if we inverse sine 1/4, we get 14.482 decimal places. So there's one solution. Now by the symmetry, this chap over here is 180 minus 14.48. So that's 165.52. Okay, so that's the 2 from that part. Now we want to do sine of x is equal to minus 1/3. So they are going to be over here. Now, if we inverse sine minus 1/3, we get 19.47 minus 19.47, sorry. So there's another one. And again, by the symmetry, this chap over here is minus 180, add 19.47. And that's going to give us 160.53. So there are our 4 solutions. Okay then, part B, hence find the smallest positive solution of the equation. 3 sine squared of 2 theta minus 30, add sine of 2 theta minus 30, add 8 is equal to 9 cos squared 2 theta minus 30. Giving your answer to 2 decimal places. Okay, so what this has done is taken the original equation and transformed it by a stretch with a scale factor of 1/2 and a translation 90 degrees to the right. So the smallest one that's going to be positive is this guy here. This is going to get stretched or squashed and translated 30 degrees to the right. So all that we need to do is set 2 theta minus 30 is equal to minus 19.47 and solve for theta. So if we add 30 to theta is 10.53. And then if we divide by 2, theta is 5.27 degrees. 13a wants us to express tan cos theta minus 3 sin theta in the form r cos theta plus alpha, where r is greater than 0 and alpha is between 0 and 90 degrees. Give the exact value of r and give the value of alpha in degrees to 2 decimal places. Okay, so we want then r cos theta plus alpha. So we're given the compound angle formulas. So r cos of theta plus alpha is equal to, well, cos of A and B is cos A cos B minus sin A sin B. So we are going to get r cos alpha cos theta minus r sin alpha sin theta. Now, if we compare that to tan cos theta minus 3 sin theta, then we can say that r cos alpha is equal to 10 and r sin alpha is equal to 3. Now from that we can say that r squared sin squared add r squared cos squared is 10 squared add 3 squared Now you can factorise the left to get r squared times sin squared add cos squared, which is 1. So we get r squared is equal to 109. So r is equal to root 109. Now, what we can also do is say that r sine alpha over r cos alpha, which is tan of alpha, well, that is equal to 3/10 or 0.3. So that gives us alpha is 16.699 blah blah blah. So, a bit funny that they wanted it to 2 decimal places because that's 16.7. So I guess we should say alpha is 16.70. Therefore then, tan cos minus 3 sine is equal to root 109 cos of theta at 16.70. Okay, next up, the height above the ground, 8 meters, of a passenger on a Ferris wheel 2 minutes after the wheel starts turning, is modelled by the equation h is equal to a, that's not alpha, so a minus tan cos of 80t add 3 sine of 80t, where a is a constant. Figure 3 shows the graph of h against t for 2 complete cycles of the wheel. Given that the initial height of the passenger above the ground is 1 meter, part B, part 1, find the complete equation for the model. Okay, so we know then that h is equal to a, then that is what we need to find the value of a. So it's a minus tan cos of 80t add 3 sine of 80t. Now we're given an initial condition. The initial height of the passenger is 1 meter above the ground. That happens when t equals 0. So t equals 0 implies h is equal to 1. So we get 1 is equal to a minus, now then cos of 0 is 1, so that's going to be minus 10. Sine of 0 is 0, so that disappears. If we then add the 10, we get that a is equal to 11. So we can write the model then as h is equal to 11 minus 10 cos of 80t add 3 sine of 80t. Now then, those two, that would be fine, you would get the marks. Those two trig terms though are the negative of what we were playing with in part A, where ATT is now theta. So, we can actually think of this as 11 minus, and then in brackets, 10 cos of ATT minus 3 sine of ATT. Now we know that when we just had theta, we know that can be written as root 109 cos of theta add 16.70. All that's happened here is theta is now ATT. So, we can write this as h is equal to 11 minus root 109 times cos of ATT at 16.70. And B part 2 says hence find the maximum height of the passenger above the ground. Okay. So, to make h a maximum here, well, we have 11 minus root 109 times the cos term. So to turn that into a maximum, we need to think of the minimum value of the cos term, which is minus 1. So the maximum occurs when cos of ATT at 16.7 is equal to minus 1. And now that is going to give us a max height of 11 add root 109. So let's work out what that gives us. Okay, if we go to one decimal place, we get 21.4 meters. Cool. Okay, then part C wants us to find the time taken to the nearest second for the passenger to reach the maximum height on the second cycle. Okay, so for that, we need to work out how many degrees the wheel has to turn to get the passenger to the maximum height on the second cycle. So, okay, what do I do here? Okay, so the passenger is going to be getting on at the bottom of the wheel. To then get to the maximum height, the wheel has to turn 180 degrees. Now that's getting the passenger to the maximum height on the first cycle. Together again on the second cycle, the wheel has to turn another 360 degrees. So, for the max height on the second cycle, the wheel must turn 540 degrees. Now the only part of our model that cares about degrees is the ATT at 16.7. So we're going to set that equal to 540. So ATT at 16.7 is equal to 540. So we take away 16.7. ATT is 523.3. And then divide by 80. We get 6.54125. So we should be fine at going 6.54. Now remember, that is minutes. And the question asked for it to the nearest second. So we need to do 0.54 times 60 to turn that part into seconds. So 0.54 times 60 is 32.4. So that's seconds. So altogether then it's 6 minutes 32 seconds. Okay, then for part D, it is decided that to increase profits, the speed of the wheel is to be increased. We want to answer how would you adapt the equation of the model to reflect this increase in speed. Okay, so think about a trig graph. What we want to do is squeeze it together. We want to make the period of the function faster. Trigonometry is all about rotations around a circle. So the constants on the outside of the trig terms, they're not going to do anything. They're just going to stretch it vertically. The value of A isn't going to do anything. That's just constant. So what we need to do then is think about the angle in the trig function. So the original model was dealing with AT. The way to speed that up is to increase the value of the coefficient of t. So increase AT to 100, maybe, something like that. Cool. Number 14. So a company decides to manufacture a soft drinks can with a capacity of 500 ml. Straight away, I'm going to write down the volume is 500 ml. Now I'm also going to turn that into centimetres. 1 milliliter is 1 cubic centimetre, so that's 500 centimetres cubed. Okay. We're then told the company models the can in the shape of a right circular cylinder. So all that means is a normal cylinder where the sides are perpendicular to the base, with radius r centimetres and height h centimetres. In the model they assume that the can is made from a metal of negligible thickness. Part prove that the total surface area s centimetres squared of the can is given by s is equal to 2 pi r squared at 1000 over r. Okay, so something to note here is that there is no h in s. So what we're going to need to do is find an expression for h in terms of r. Now to do that we use the volume of the can. So the volume of a cylinder is pi r squared h. So we know that pi r squared h has to equal 500. So h is equal to 500 over pi r squared. Okay, so now that we know what h is in terms of r, let's think about surface area. So, cylinder has 3 faces. It's got 2 circles. And it has the rectangle that wraps around the outside. Now we know the height of the rectangle is h, which is 500 over pi r squared. Now we know the radius of the circle is just r. Now the length of the rectangle is the circumference of the circle, so that's 2 pi r. So, S then is 2 lots of the circle, so that's 2 pi r squared. Add 2 pi r times 500 over pi r squared. Now, okay, so we have S is 2 pi r squared. Now the 2 in 2 pi r is going to multiply 500, so that's going to give us 1000. The pi's are going to cancel out, and one factor of r is going to cancel on the bottom, so we do just get 1000 over r. And then for part B, given that r can vary, find the dimensions of a can that has minimum surface area. Okay, so when we're thinking about minimums or maximums, we should be thinking about derivatives. So now that we know S in terms of one variable, we can differentiate it, set it equal to 0, find the value of r. When we know the value of r, we can get the value of h. So, I've rewritten the expression for s as 2 pi r squared, add 1000 r to the minus 1, so then ds by dr is going to be 4 pi r minus 1000 r to the minus 2. Now I'm going to write that back in fraction form. So that's minus 1000 over r squared. Now we should probably say for a minimum ds by dr is equal to 0. Which then leads us to 4 pi r minus 1000 over r squared is equal to 0. Now if we multiply through by r squared, we get 4 pi r cubed minus 1000 is equal to 0. Add 1000 and divide by 4 pi, then r cubed is 1000 over 4 pi. Cube root, and that gives us r is the cube root of 1000 over 4 pi. Which, even if we go to 2 decimal places, is actually just 4.3. Now, sometimes in these questions you also need to check that this would give a minimum value. To do that, you would find the second derivative, substitute in the value of r that we found, and for it to be a minimum, the second derivative would need to be greater than 0. As it goes though, for this one, we don't need to. So now that we know R, we can work out H. Remember that in part A, we used the volume pi r squared H was equal to 500. H then was equal to 500 over pi r squared. So 500 over pi times 4.3 squared. It's going to give us a number so that gives us, again we'd probably be right going to 1 decimal place, but 2 decimal places, this is 8.61. And of course, both measurements are in centimetres. Okay, then part C, with reference to the shape of the can, suggests a reason why the company may decide not to manufacture a can with minimum surface area. So, think about the measurement that we've just found, or the length we've just found for the radius, 4.3 centimetres. It's going to give us a diameter of 8.6. Now that is really big. If you look at a can of Coke, they're nowhere near that size. So I reckon we would say the radius is far too big, making the can far too wide, and it just wouldn't be efficient to put on shelves because it would take up too much room. Number 15, a nice 10-mark question. So, figure 4 shows a sketch of the curve with equation y equals 5x to the 3 halves minus 9x and 11, where x is greater than or equal to 0. The point P with coordinates 4, 15 lies on C, so let's put them on there. Okay. Then we're told the line L is the tangent to C at the point P. The region R, shown shaded in figure 4, is bounded by the curve C, the line L, and the y-axis. We want to show that the area of R is 24, making your method clear. Alrighty then, so, big things. So, there are 3 bits of area that we're interested in. What we can do, if we integrate the curve between 0 and 4, that's going to find us that whole area. So, the part of R above the x-axis and the white triangle above the x-axis. Now we don't want the white triangle. What we're then going to need to do is find the equation of the tangent, find where it cuts the x-axis. That's then going to allow us to find the area of the white triangle. And we're also then going to be able to find the area of the little shaded triangle below the x-axis. So, lots to do. So, I think, first of all, I'm going to do the integrating. So, let's call these regions, we'll call the part that we don't want A1, then we'll call this part of our A2, and then we'll call the little tiny bit, we'll call it A3. Okay, so we know then that A1 and A2 is the integral between 0 and 4 of the curve. So 5x to the 3 halves minus 9x add 11. Lovely. With respect to x. Okay, so that is going to give us, right, x to the 3 halves integrates to x to the 5 halves. We divide by the new power. When you divide by a fraction, you flip it and multiply by it. So we're going to get 2/5 x to the 5 halves. That's also being multiplied by 5, so the 5's cancel out, so we just get 2x to the 5 halves. Now x integrates to 9 halves x squared. And 11 becomes 11x. And that is from 4 to 0. Okay, so now if we plonk in our limits. So 4 to the power 5 halves is 2 to the power 5, which is 32. Times, and then we got the 2 on the outside, so that's 64. Minus 9x squared over 2, so 4 squared is 16. If we divide that by 2, that's 8. Times it by 9, 72. And then add 44. Now, when we put in 0, all of the terms disappear. So, this is our answer for this bit. So, we have 64 and 44 is 108. 108 minus 72 is 36. So, let's just recap. What we now know then is that the area above the x-axis under the curve is 36. So, we now know A1 add A2 is 36. Okay, right, next up. We're now going to need to find the equation of the tangent. Okay, so let's call this the equation of L. So we're going to need to differentiate y to get the gradient. So dy by dx is going to be so the power of 3 halves comes down and multiplies the 5, so that's going to give us 15 halves x, and then the power goes down by 1, so it goes down to 1 half. So it's going to be 15 halves x to the half. And then we're going to get minus 9. So, to find that's the gradient function of the curve, to find the gradient at P, we substitute in x is equal to 4. So, 4 to the power of a half is 2. 2 times 15 halves is 15. So we have 15 minus 9, which gives us 6. So we now know L is of the form y is equal to 6x add c. To find c, we substitute in the coordinates of P, which are 4, 15. So 15 is equal to 6 times 4, 24. Add c, which tells us on c is minus 9. So L is, L is the line y equals 6x minus 9. So, now that we know that, we now know that the y-intercept down here is minus 9. What we need to find is this x-intercept. So, here, y is equal to 0. So that tells us 6x minus 9 is equal to 0. So 6x is 9, so x is 3 halves. Okay, so what we can now do is work out the area A1. So A1 is a triangle with a base of 5 halves and a height of 15. So A1 is 5 halves or 2.5 times 15 all over 2, area of a triangle, and that gives us 18.75. Now remember that we know A1 and A2 is 36, so we can now work out A2, which is part of what we want. So A2 is 36 minus 18.75. And that gives us 17.25. So all we need to do now is find the area of A3 and add that on to 17.25. So A3, again it's a triangle, this time it has a base of 1.5 or 3 halves and a height of 9. So this time we're doing 1.5 times 9 over 2. Now that gives us 6.75. So then A2 or R is 17.25. Add 6.75, which very happily is 24. Okay, finally the final question. So we want to part A express 1 over p times 11 minus 2p in partial fractions. Okay, so for part A then, we can say that 1 over p times 11 minus 2p is equal to a over p add b over 11 minus 2p. Now, using the old cross multiplication method with fractions, we know the top would become, so we would multiply a by 11 minus 2p, so that would give us 11a minus 2ap and then we're going to add b times p. Now we're not going to do the bottom would just be p times 11 minus 2p. We do know, however, that the top has to be equal to 1. So that means then that 11a has to be 1, so a is 1/11th. And then we don't want any p's up on top, So we know that the coefficients of the p's have to add together to 0. So that tells us, now that we know that a is 1/11th, this tells us that minus 2/11ths add b is equal to 0. So b is equal to 2/11ths. So that means then that 1 over b times 11 minus 2b can be written as 1/11th over b add 2/11ths over 11 minus 2p. Now that doesn't look very neat. So if you have a fraction up on top, that just means that fraction is multiplying the overall fraction. So we can write this as 1/11p add 2/11 times 11 minus 2p. Okay, here we go then, this bit's going to be fun. So, the population of meerkats is being studied. The population is modelled by the differential equation dp over dt is 1/22p times 11 minus 2p, where t is greater than or equal to 0, p is between 0 and 5.5, where p in thousands is the population of meerkats and t is the time measured in years since the study began. Given that there were 1,000 meerkats in the population when the study began, part B answers to determine the time taken in years for the population of meerkats to double. 6 marks. So, what we need to do is solve the differential equation to get. Okay, so the first thing we need to do is get the p's on one side and the t's on the other. So, we can multiply through by dt and divide through by p times 11 minus 2p. So, we are going to get dp over p times 11 minus 2p is equal to dt over 22. Now, using what we did in part A, the left-hand side can become well, there's a common factor of 1/11, so we can write the left as 1/11th (1 over p) add 2/11 minus 2p. dp dt over 22. Now if we multiply through by 22, the 1/11th goes and we just multiply the tops of the fractions by 2. So we now get 2 over p. Add 4 over 11 minus 2p. dp is equal to dt. Now we're going to integrate both sides. So the integral of 2 over p is 2 log p. Now then, the integral of 1 over 11 minus 2p would be minus a half log of 11 minus 2p. So we have 4 times minus a half that log, so we have minus 2 log of 11 minus 2p, and then when we integrate on the right, we just get t and c. Okay, so now what we need to do is find the value of c. So remember we were told the initial population was 1000. P is thousands, so we're just going to use P is equal to 1 when T is equal to 0. So, when T is 0, P is 1, so that tells us, well, 2 log of 1 is 0, we get minus 2 log of 9 is equal to C. Because T is 0. So, now we know then that 2 log of P minus 2 log of 11 minus 2p add 2 log of 9, so I'm adding c to both sides, or I'm adding the value of c to both sides. So add 2 log 9 is equal to t. Now we want the population to double, so that means we now want p is equal to 2. So p equals 2. Gives us t is 2 log 2 minus 2 log 7 add 2 log 9 like that in your calculator, and thankfully we get 2 decimal places. T is 1.89 years. Okay, then the final part wants us to show that b is a over b add c e to the minus 1/2 t, where a, b and c are integers to be found. Okay, so this is going to come then from the point where we found the value of c. So this is the situation we find ourselves in. Now, something really handy to notice here is that every log term has a 2 on the outside. So if we divide through by 2, we get log p minus log 11 minus 2p is equal to t over 2 minus log 9 Okay, now if we add log 9 to both sides, then we have log 9 add log p, which is log 9p. So we can get log 9p now that's then minus log 11 minus 2p. So we can combine that as well to get log of 9p over 11 minus 2p. And that is equal to t over 2. Okay, now exponentiate both sides, and we get 9p over 11 minus 2p is equal to e to the t over 2. Now then, if we multiply through by the bottom, 9p is equal to 11e to the t over 2 minus 2p e to the t over 2. Now we're trying to make p the subject, so we need all the p's together. So add that last term, we get 9p, add 2p, e to the t over 2, is equal to 11 e to the t over 2. Factorise the left, b lots of 9, add 2 e to the t over 2, is equal to 11 e to the t over 2. Divide by the bracket, b is equal to 11 e to the t over 2 over 9 add 2 e to the t over 2. Now that's not quite the form they wanted in. We want an e to the minus t over 2. So we're now going to divide the top and bottom by e to the t over 2. Now that is finally going to give us 11 over 2 add 9 e to the minus t over 2. Boom. On that, guys, the paper is done. Really hope you found it useful. It got really hard here at the end. Don't forget, give us a thumbs up, get subscribed, drop us a comment with any requests. Take it easy, take care.